Hello students, welcome to the session. This is Boolean Logic, class 11, chapter 3. Let's get into the lesson. Boolean logic, the mathematical system of logic, was developed by George Boole, and this led to the development of a system called Boolean algebra, also called as Boolean logic. So this Boolean logic is used to solve relays logic problems that helps to solve logical problems that involve binary decisions. What do you mean by binary decision? Any decision that results in either a true or a false is called as a binary decision. So what do you mean by the term binary valued quantities? So binary valued quantities are either you will get a yes or a no as the possible answer, right? So look at these statements. 20 minus 10 is equal to 10. If someone states this and you have to check the validity of this statement, you will say either yes or no. So this statement is called as a logical statement. Which is your favorite color? Now this kind of a statement will not result in a true or a false because you will have some answer but not a true or a false, right? So who is your friend is a different kind of statement which will not result in true or false. But look at statement 4. Chennai is the capital of Tamil Nadu. This is true, so you will say true as the answer. Suppose something else is given here, you will give false or you will say no. So out of these 4 statements, statement 1 and statement 4 give you the result as either true or false, that is yes or no. So first statement and fourth statement is called as a logical statement. The other two may give different answers, so they are not called as logical statements. Okay, so I summarize again. Any statement that results in the answer true or false or a yes or a no is called as a logical statement. So there are some important terms which you have to learn in this lesson. The first one is the binary decision. What do you mean by a binary decision? When you make a decision which results in a true or false, that is yes or no, is called as a binary decision. So the terms true and false are called as truth values. Okay, and Boolean variables are only two values, true, false. True is represented as 1. False is represented as 0. So whenever we work with logical statements, we will always use 1 and 0 instead of true and false, right? And truth table, this is one important term you should know. So whenever we have a logical expression, we will represent the logical expression in the form of a tabular column which is called as a truth table. In the truth table, we will give different combinations of input values and get the result of any logical expression. That table is called as a truth table. So very soon we will learn how to draw a truth table, right? And two other important terminologies, tautology and fallacy. What do you mean by tautology? When you are given a logical expression, say for example, x and y or z. This is a logical expression. If the logical expression gives the answer as 1 for all inputs. Suppose you have 8 inputs, you have 4 inputs, you have 16 inputs. All the inputs result in 1. Then that expression is called as a tautology. So you already know binary answers are only either 1 or 0. So sometimes you will get 1, sometimes you will get 0. But when the answers in a tabular column, that is a truth table, is always 1, then that expression is called as a tautology. Same way, if the answers, all the inputs are results in answer 0, that expression is called as a fallacy. Okay. Now, what is a logical statement or what is a logical expression? First, we will give a generalized statement. For example, he prefers coffee, not tea. So you can assign coffee as variable x and t as variable y. So you can say x, not y. That is a logical statement. He plays guitar and she plays sitar. So if you assign a value, you will get a logical statement. I watch TV on Sundays or I go for swimming. So look at the keywords and, or, not. So these and or not are called as the logical operators. So when we use them in expressions, you will understand how to work with these operators. Okay, these are operators like how arithmetic operators we use plus, minus, multiplication, star, slash. Same way, logical operators are and, or, not. Okay. So we'll move on to the important topic, logic gate. So what is a logic gate? A logic gate is a simple electronic circuit. It's a basic circuit which operates on one or more signals. So you will have an input signal. Based on the input signal, a circuit will produce an output signal. Where are these used? These are used in a lot of electronic devices. There are a lot of electronic devices which we use every day, right, in our day-to-day life. So we switch on certain options, we switch on certain options, we switch off. Accordingly, the device works. How does it work for all input combinations? Say you use an induction stove, you use an oven. There are a lot of options. Few options we switch on, few options we switch off. So accordingly it works. How is it designed? That electronic circuit is fixed with lot of logic circuits inside. Lot of small electronic circuits are grouped together, and according to your input the output is given, right? So first we will learn three basic logic gates. The AND gate, OR gate, NOT gate. These are very basic for circuits. Okay. So how does a NOT gate work? A NOT gate works exactly opposite to the input given. Suppose you give an input as 1, the output will be 0. You give an input 0, the output will be 1. So NOT gate is called as complementation. Complement means opposite. So how is an opposite expressed? Suppose the input is called as A dash, A bar. There is the small line on top, A bar is called as its complement. So if the input is X, X bar is called as the complement. So how does a NOT gate work? A NOT gate works when we give an input, it gives the opposite output. Okay. OR gate, there is a symbol called plus symbol. OR gate is represented by the plus symbol. You can either say X plus Y or X or Y. How does the OR circuit work? When you give an input, it will give a high output if any one of the outputs. So I told you this AND OR NOT circuits are used to construct electronic circuits in small devices, or in all electronic devices we use AND OR NOT, right? So to make it real, that is the AND OR NOT operator, what did I tell you? AND is the multiplication operator, OR is the addition operator, NOT is the complement operator. To make it true, we have small circuits that are available. Okay, so logical addition is performed by a circuit called OR gate. Logical multiplication is performed by a circuit called AND gate, and logical complementation is performed by a gate called NOT gate. So these are the symbols. Okay, so this is the OR gate, this is the AND gate. Look at the shape, how it appears. This is curved here and is pointed. This is straight here and is bent this way, and a NOT gate is a small triangle with a small pointed circle, right? So these are the symbols for OR, and NOT gate. So we should learn these two lines represent the input and this line represents the output. Same way here we have two inputs and one output. NOT gate, one input, one output. Okay. We can have more than two inputs in OR and AND gate, whereas NOT operator always operates with one input and one output. Okay, so we'll see how these circuits work. Okay, now how does the AND gate work? Let me show you. As shown in the picture, the AND gate is represented in this symbol, right? So you have say two inputs A and B. This is what gate? This is AND gate. AND gate I told you is the multiplication operator represented by dot. So you are giving an input called A and another input called B. So what will be the output? A multiplied by B, that is A dot B will be the answer. Right? Now, how do you give the input? Suppose this is a circuit. You put this A as 0 and B as 1. The signal is 0 here and 1 here. What will be the answer? Suppose A is on and B is off. What will be the answer? Suppose A is on, B is also on. Both values are high. What will be the output? Suppose A is off, B is also off. What will be the output? So like you have different combinations of input. Like how you do probability. What are the different combinations? Consider this as like a switch. You switch on A, switch off B. Switch on B, switch off A. Switch both A and B on, switch both A and B off. So for all these input combinations, what will be the answer? This is how an AND gate works. So let us see how it works. So you have two inputs A, B and the answer is A dot B. So what are the different input combinations? Both are off. B is on. A is alone on. Both A and B are on. So these are the different input combinations. So for two inputs there are four input combinations, that is 2 power 2. 4 input combinations. Okay. Now the rule of dot operator, that is multiplication operator, is whenever there is 1 0, any 1 0, answer will be the 0. That is the rule of AND operator. When you use an AND circuit, when any one of the input is off, the output will also be off. The output will be low. That is 0 is called as low and 1 is called as high. But look at this. Here in this fourth condition, both the inputs are high. So the output will also be high. So tabulating this box, tabulating the inputs, the different kinds of inputs and showing what output it gives is called as a truth table. This is called as a truth table. This is the truth table for what? AND gate. So what is a truth table? A truth table shows the different kinds of combinations of input and what output they give. Suppose there is a 3 input AND gate. 3 inputs are there. You can construct a circuit with any number of inputs. There are 3 inputs A, B, C and 1 output. What is the output of an AND gate? It is a multiplication, right? A dot B dot C. How does the inputs work? You have 3 switches A, B, C. I am asking you to consider this as a switch so that you can imagine how it works. Suppose you switch off all. There is no input that is passed. Then the output will be 0. Suppose A and B are low and C is high. It is 0. Suppose B is alone high, other things are 0, it is also 0. So this has a 0, so output. Why I am putting a 0 here? According to the rule of AND gate, that is logical multiplication, any 1 0 will result in a 0, right? So 1 0 0, 1 0 1, 1 1 0, 1 1 1. I have given all the input combinations. Now check the zeros here, so all the inputs will be 0. Now when does it result in a 1? When all 3 inputs are 1, then the output will be high. All the remaining things, the output is low. So this is the truth table for a 3 input AND gate. Right? So for a 3 input AND gate, there will be 2 power 3, that is 8 input combinations. Suppose there are 4 inputs A, B, C, D, 2 power 4, that is 16 input combinations. So you have to put 16 rows of input combinations and show what the output will be. What will be the output? Only if A, B, C, D, all 4 are 1, the output will be 1. So this is how an AND gate works. right? Now let's move on to OR gate. AND gate is represented by this symbol. So there are two inputs A and B, output is A dot B. How does it work? Gives 1 for all inputs being 1. Okay. The same when it goes for OR gate. How is an OR gate drawn? Here is a bend and there is a pointed tip, and this is the representation of OR. What do you mean by OR? Plus symbol, addition symbol. How is the output given for OR gate? It gives 1 for any input being 1. If any one input is 1, the answer will be 1. Okay. So how is it represented? You have A, B. Two inputs. What is A plus B? 0, 0, 0, 1, 1, 0, 1, 1. So for all input combinations, if for any input being 1, so here you have a 1, here you have a 1, so output will be 1. But here both are 0, so the output will be 0. So this is the truth table for OR operator, that is OR logic circuit OR. Okay. Now, how about a 3 input OR gate? Suppose you have X, Y, Z given in an OR gate. What is the output? X plus Y plus Z. What is the rule for OR gate? If any input is 1, output will be 1. So how do you write the different input combinations? 0, 0, 1, 0, 1, 0. This is the same as your octal table. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the different input combinations. Now what is the answer of an OR gate? If any input is 1, output is 1. So only for this the answer will be 0. For the rest of all the inputs, answer will be 1. This is the condition for OR gate. Okay. Next we move on to NOT gate. NOT gate I already told you. For NOT gate there is only one input and one output. NOT gate is represented this way. If X is the input, X bar is the output. If you term the input as A, then A bar is the output. Okay. So gives 1 for 0 and 0 for 1. So if you give 0 as the input, output will be 1. If you give 1 as the input, output will be 0. So very simple, only two input output combinations. Okay. So this is a NOT gate. So this is the truth table for NOT gate. NOT gate is called as the complementation. What do you mean by complement? The opposite of the input. Given input is 0, output is 1. Given input is 1, output is 0. So these are the basic input combinations, and I have given the truth table for AND gate, OR gate, NOT gate. How do you write an expression? X plus Y minus Z into W, something like this. So these are called the arithmetic operators which we use in mathematics, right? So in Boolean expressions, we have three operators: plus, dot, complement. This is called as plus operator or called as OR operator. This is called as multiplication. This is logical multiplication, otherwise called as AND operator. The dot operator is called as multiplication operator, which is represented as AND. Plus operator is the addition operator, which is called as OR operator. Okay, and this is not minus. This is put on top of the variable A bar, X bar. Complement. This is called as complement operator. So what is complement operator? A small dash which is given on top of the variable is called as the complement operator, right? So this is also called as NOT operator. So what are the three Boolean operators? AND, OR, NOT, which is represented by dot, plus, bar, that is the complement operator. So these three are the basic Boolean operators. Now we'll learn how to write or draw a truth table for a given expression. So you may be given an expression and asked to draw a truth table for that logical expression, or you may need to prove or verify a given expression using a truth table. So these are the two kinds of statements you will need to draw the truth table for. So let us look at this question, the sample question. Using Boolean logic, verify using truth table that x plus xy equal to x. Right? So how to draw the truth table for that? You have to prove that using the truth table, you have to prove x plus xy is equal to x. Now how do you draw the truth table for this? Now find out how many variables are used here. You have two variables x and y in this expression. So put x and y. If you have two variables, you will have 2 power 2 4 input combinations. So when there are two variables, you will have 0 0 0 1 1 0 1 1. So 4 input combinations. Now what is the first part of the expression? X, which is already there. What is the second part? xy. xy means x into y. What does dot stand for? Dot stands for AND, logical AND operation. What is the truth table for AND? For an AND logic gate, only when both the inputs are high, the output will be high. So when you have multiplication, both should be 1 to get a 1 here. When at least one input is 0, the output will be 0. So when you have dot, that is multiplication, any 1 0 will get a 0. Only when both inputs are, all 3 inputs or all 4 inputs are 1, answer will be 1. So second part also we have now. So you have to now form x plus xy. So write the expression x plus xy. Now where is x? Here. Where is xy? Here. You have to add x plus xy. What is addition? Logical addition means if there is any one value is 1, then the output is 1. So here check x plus xy. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0. So any 1 means output is 1. Here also both are 1s. So output is 1. So logical addition means not 1 plus 1 equal to 2. That is wrong. In addition, the rule is 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is also 1. Okay. So any one input is 1, output will be 1. So now look at the answer, the LHS. Where is the LHS? Here. Where is RHS? Here. Now check if both are equal. This is 0 0 1 1. This is 0 0 1 1. So hence it is verified. Right? Hence x plus xy is equal to x. This is how you prove an expression using a truth table. Now look at the second question. Using Boolean logic, verify using truth table that x plus y whole bar, x plus y complement. This bar, this stands for complement. X plus y whole bar equal to x bar y bar. So how will you do this? X plus y whole bar is equal to x bar dot y bar. Now again check how many inputs are there? 2. X, y. So 0 0 0 1 1 0 1 1. So first fill in the input combinations. Now first get the LHS part. What is LHS? First x plus y you have to bring. X plus y, that is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is also 1. But we need x plus y bar. What is x plus y whole bar? It is the complement. X plus y's complement is x plus y whole bar. X plus y whole bar means opposite of this. Complement means the opposite. So for 0 complement is 1, 1's complement is 0. So we have got the LHS. LHS is now ready. Now let's move on to RHS. X bar dot y bar. So first you have to find x bar. X is here. What is x complement? The opposite. So 0 0 1 1 means you will get 1 1 0 0 as the complement. Then what is y complement? 0, 1, 0, 1 is y. So 1, 0, 1, 0. The opposite will be y dash. Right? But actually what you need? X dash dot y dash, that is multiplication. AND operator. X bar dot means AND operator. For AND, if both ones means, then you will get 1. Any 1, 0 will get a 0. Right? So RHS is now arrived. Right? So you have to prove LHS equal to RHS. Now check, LHS is 1,000,000, RHS is also 1,000,000. Hence it is proved that x plus y whole bar equal to x bar dot y bar. So this is how you have to verify the truth table. Now let us check some simple logical expressions. You have to draw the truth table. X dot y bar plus z bar plus x y bar, right? X into y bar plus z bar plus xy bar. So this is the expression. So now how do you find it? So first you check how many variables are used here. You have 3 variables x, y, z. So put x, y, z. For 3 input variables you will get 8 input combinations. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1 finally. So 8 input combinations. Now first do the brackets part, y bar plus z bar. So find y bar, z bar, y bar plus z bar. So what is y complement? The opposite of y. 0, 0, 1, 1, 0, 0, 1. What is the opposite? 1, 1, 0, 0, 1, 1, 0, 0. What is z complement? Opposite of z. So give the opposite of z, 1, 0. Right? Now addition of these two. So here both are 1s, here 1 is there, here 1 is there. Here both are 0, so 0. Here 1, 1, 1, but the last one is 0. So y bar plus z bar is ready. Now you have to find x into y bar plus z bar. So y bar plus z bar is here, x is here. You have to multiply these two and put it here. So check this. 0 into 1, 0 into 1, 0 into 1, 0 into 0. All 4 are zeros because any 1 0 will give us 0. Right? Now here 1 1, 1 into 1, 1 into 1. So both are 1s. So you will get the output as 1. But here 1 into 0. So output is 0. So first part is over. Now you have to keep this as expression 1. This is x into y bar. Where is x? Here. Where is y bar? Here. So x into y bar. So 0 into 1, 0 into 1, 0 into 0, 0 into 0. All 4 are zeros. 1 into 1, 1 into 1. So 2 1s. Then 1 into 0, 1 into 0. So 2 zeros here. Now keep this as 2. So 1 plus 2 will give the final expression. Because you need not write the entire expression here. So 1 plus 2 will give the final answer because this is plus. So 0 plus 0, 0, 0, 0, 0, 1, 1. Here 1 plus 0 is 1, 0. So this is the final answer. So this is how you draw a truth table for a given expression. Okay. We'll see one more example. X, y, z bar plus x bar, y bar, z. X, y, z bar plus x bar, y bar, z. So x, y, z, you will have 3 input combinations. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1. X, Y, Z bar. X, Y is already there. Z is there but Z bar is not available. So let me do X bar, Y bar, Z bar, everything because we need all this. So what is the x bar? Complement of x. So 4 zeros, 4 ones. So here you will have 4 ones, 4 zeros. For y bar, 2 ones, 2 0, 2 1, 2 0. Then for z bar, 1 0, 1 0, 1 0, 1 0. The opposite of x, opposite of y, opposite of z. Now frame this expression. Expression 1 is x into y into z bar. So 3 variables you have to multiply. X into y into z bar. So check if all 3 are 1. So first check in which input all 3 are 1. See, if any place, here you have all 3's as 1. But here it is 1, 1, 0. So all the remaining answers are only zeros. Okay. Next we get x bar, y bar, z. X bar, y bar, z. This is the second part. So where is x bar? X bar, y bar, z. So this is very easy. So here you have a 0. Here you have a 1. This is 0. Here is 0, 0, 0. So all the others are 0. So in AND gate, that's multiplication. Any one 0 will fetch a 0. Now what is the final answer? This first expression plus second expression will give the final answer. 1 plus 2. So here there is a 1. Here there is a 1. The remaining values are all zeros. So how will you draw a truth table? Find out if it is multiplication or addition. For multiplication, the rule is if both inputs are 1, output is 1. For addition, if any one input is 1, output is 1. Okay. So this is how you solve a truth table. Hope you understood. Thank you. In the next video, you will learn about the basic postulates of Boolean algebra, the principle of duality, principle of complementarity, De Morgan's law, and the algebraic proof of all the other laws. And in the third video of this chapter, you will learn about the remaining logic gates like NOR gate, NAND gate, XOR, XNOR gate, and how to draw the logic circuit for the given expressions. Thank you.